Hello, welcome. Let's look at this problem and hopefully you're not getting bored. However, please pay attention to this video if you're looking for help with your homework or either with your exam prep. I think this is really going to help you out. So, without further ado, let's look at this problem real quick. The cost in dollars of producing X units of a certain commodity is this function we have, as we can see. Find the average rate of change of C, this function, with respect to X, right? C of X, when the production level is changed from X is equal to 100 to X is equal to 105. And another part of this problem is from X is equal to 100 to 101. So make sure you all have calculators for this problem. And if we all familiar with rate of change, which is basically change in X divided by change in, excuse me, see, I'm already making mistakes here. It's change in Y or change in X. We can also call this delta Y or delta X. Okay, let's start plugging. And we can already see here X1 is 100, right? It's changing from 100 to 105. So change in Y is basically if we plug in these values in this function, right? Minus f of x1. Okay, continuing with this problem here now. Let's just plug in the values real quick. So f of x2, which is 105, is what? This is, you can also write physically if you want, C of 105 C of 100 divided by 105 minus 100. So let's just plug in the value into this function. So this is going to be 5000 plus 10 times 105, which is 10 times 105 plus 0.05 x to the square, which is 105 to the square, minus of C of 100. I'm going to do the plug-in again. 5000. So minus times plus positive 10 of x. So this is going to be, okay, we can just use this here first. Let's just plug in the numbers here first. Plus 10 times 100 plus 0.05, 100 to the square. Okay. Divided by 105 minus 100, which is 5. Let's just simplify this expression real quick. 10 times 105 is what? 1050 plus 0.05 multiplied by 105 to the square. This is equal to 551.25. Now this is minus 5000. This is again minus 10 times 100 is 1000, right? And positive times negative is what? Negative of 0.05 multiplied by 100 to the square, which is 500 divided by 5. 5000 cancelling each out. We can simplify this expression now, which is 1050 plus 551.25 minus 1000 minus 500, which is equal to 101.25 divided by 5, which is equal to 20.25. Now, what we are being asked here is the cost in dollars of producing X units of a certain commodity and find the average rate of change of C with respect to X production level is changed from this. So, this is going to be $20.25 per unit. Okay, it's better to add at front, right? Dollar sign per units. And same is for this one, right? When it changes from 100 to 101, then what is the average rate of change? Then for this example, I'll just, please try this, just same thing, right? Just plug in the values here, where x1 is equal to 100 and x2 is equal to 101, and use the same thing as here, and you will see that I'll just give you the answer for your reference. So you will end up with $20.05 per units for this one. Okay, here's your answers. And the next part of this problem is this: find the instantaneous rate of change. Find instantaneous rate of change of C with respect to x when x is equal to 100. Now, if you remember, so in this problem, what is the difference is here? We are trying to find the instantaneous rate of change of C of this function C with respect to x when x is equal to 100. So again, for instance rate of change, if you might remember, the limit as change in x approaches to 0 is change in y over change in x, which is function as x2 minus x1. Now in this, we are trying to, with respect to x when x is equal to 100, instantaneous rate of change. And so we only know one value, right, which is 100. Okay, let's just plug in the values here real quick. So what we have here handy is expression 5000 plus 10x plus 0.05 x square minus f of x1. F of x1 is what? We already have this expression here, right? If we can just use it from here, and let's see what it comes down to. So 5000 plus 10 times 100, which is 1000, plus 0.05 multiplied by 100 square. So we are ending with 6500. I see what we are doing here, right? So we are just simply putting the values here in C, in the function C, right? X of 2, which, and then C x of 1, which is given 100, divided by x2 minus 100. Okay, so it's a full screen here for better. Okay, so let's simplify this further, right? What we end up with is 10x plus 0.05 x square. 5000 minus 6500 is what? 1500. Yep, negative. So it's negative 6500 plus 5000. So this is going to be negative 1500 divided by x2. Okay, see, I'm already making the common mistake. This is simply x, right? We are trying find the instantaneous rate of change with respect to x when x is equal to 100. We don't have the value, right? Because for this x2 value, so we are keeping it as x minus 100. Okay, let's see if we can simplify this further. So we can have this common somewhere here. Okay, so even if we simplify this expression a little further, things are looking very complicated to me already. I definitely did not like this approach at all. So I'm gonna try doing this problem another way. Since we are being asked to find the instantaneous rate of change of C with respect to x when x is equal to 100, how about if we just, which is already pretty clear, right? We are finding a derivative. So what if we do with respect to x before we plug in the value and just simplify the definition here? So the derivative of this function c with respect to a, right? Because we have been given this value already. X is equal to 100, which is value, right? A, as x is approaching 100. Okay, let's try this way. Limit as x plus function c of x and c of a and c. Okay, let's start plugging the value into this function. So c of x is 5000 plus 10x 0.05 x square minus c of a. So instead of x, we are going to plug in a here. These are going to be cancelled out. So what we are left with 10x plus 0.05 x square. Negative times 10a is negative 10a minus times positive 0.05 is negative 0.05 square. Okay, we can simplify this, right? And taking 10 common, what we are left with x minus a. And taking 0.05 common, we are left with x square minus a square divided by x minus a. Limit as x approaches to a, x minus a plus 0.0. What I know you can already tell as well. We can take x, if we apply the formula here, a square minus b square, which is equal to a plus b, a minus b. We can take x minus a common and then this will cancel out, right? So we are going to do that, x minus a, x plus a divided by x minus a. Excuse my handwriting as well. It's giving really hard time. Limit as x approaches to a of this. Taking x minus a common factor, x minus a. What we are left with is 10 plus 0.05 times x plus a divided by x minus a. Cancels out, right? We are left with limit as x approaches to a 10 plus 0.05 x plus a. And as x approaches to a, this expression drops, right? So we are left with 10 plus 0.05 a plus a. A plus a, which is 2a, right? So 10 plus 0.05 times 2a is 0.1. Okay, here we go. So now we have the derivative of this function, which is 10 plus 0.1a. And the question we were given is find the instantaneous rate of change of this function cx with respect to x when x is equal to 100, right? Okay, here we go. So what we can do is now we can just simply plug in the value here, right, into this as a approaches 100, right? Limit 10 plus 0.1 multiply by 100, and this is equal to 10 plus 10, which is equal to 20. And since we are looking at the production level, so this is going to be $20 per unit. Okay, I really hope this helps, and please put in the chat if you have a easiest way to follow the expression following from here. But I definitely recommend this approach, as this simplifies it better than this and saves time in exam time, right? So yeah, thank you.